Hi, good morning everybody. I got couple of requests to do this room x86 assembly crash courses. Be clear, I'm not expert in this field, so I'm just doing it in case it will help someone. So basically this is simply language. Usually we get some rooms in TryHackMe regarding this reverse engineering, things like that, in machine code, the opcode, the operand, is assembly instruction, logical math. This is the only way to learn it, is practice. So the first tasks, especially 3, 4, 5, 6, 7, all of them, most of it like general general information of the code, like the opcode or number that correspond to instruction performed by the CPU. So basically, like say if I move ex2, so let's be clear, the last part is the one that we move in. So move this value to this to eax. So usually when you use Ghidra or something, usually we see them in this type of I don't have Ghidra here, so usually we see always this type of numbers. And I remember we use these rooms also in TryHackMe for malware analysis. You get this lot also. um, they treat the open code, they translate them into assembly instruction to make them human readable. For example, the instruction moving 0x5 5f to the x registry. I said this is the last value, is the one that we move. It is like a reverse, so you don't confuse like a Linux command move something to that. In fact, you're moving the last part to the ex. So basically, of course, this you should read about it. I'm not doing it in case people stuck in this one, but the rest you can read and go for it. So typo operand is in general, there is immediate operand, can also consider constant. This is a fixed value like we have like this. Register usually this, and then the memory one is one you see them is a bracket behind them, so you don't confuse with them. If there is bracket, so it's not a registry, it's the memory. So we have the registry, we have the memory, and then immediate operand. What do you call this? Operands. You can't really learn this too much without practice, so this room take it as more like an introduction or something. If you want to learn more, you need to go deeper to understand this. It's not like how these numbers, you can understand basically the simple terms here, like move this to that. For example, what's the hex code that denotes the assembly operation called? Basically is this the operand, the what they call the opcodes. The opcodes are the numbers that correspond to instruction performed by the CPU when we use disassembler. So let's go quickly to this. Which type of operand is denoted by square bracket? Remember we said the square bracket is a memory one, so this is very important to get them later on when we start, like for example here, to understand this instruction here wherever. So you don't confuse when you see the bracket is a memory, is not is a register. So this is very important. Now for example this the move instruction. So basically moving this value, the source to the destination. Destination is the first part. So for example we move this to the ex register, this to the ebx. This is memory here, that's why we have we move in the value in the memory location. So we move in whenever this bracket, it's memory. We can use plus, adding an offset of 5 bytes to memory. So this is all more like instruction mathematical things or something. The Lee instruction stands for load effective address. The format of this instruction load while many, what exactly this do? Yeah, add 4 bytes for example. We had used move instruction here instead of the, it will move the value in the memory location. Okay. The NOP, you know, it also more of the time in malware analysis it's been used. You see when we said a NOP value, I remember these rooms and TryHackMe about this, that hacker use when they use is used by malware author when redirecting exclusion to their shell code. So shift instruction, shift left, shift right. This is also, I think they're using it, it's a bit faster than multiplication. So instead to say multiply by 2, you just shift, because now it's on the way that hex work. So you shift by 1 the count, for example, given example. So we have in x, and shift is left, would be shift left, so we go in this direction. So add 0 from the right. So we shift in the number. Wherever we shift, we add zeros. Again, this is more how to say it. And then rotate again, the same thing, don't try hard to understand this. If you don't practice this like malware analysis or some kind of reverse engineering, you just need to memorize for now. It's not really something you learn it by reading it. It's practice. I said I'm trying my best in case someone get. Let's see, if in move x abx which register is destination. We know destination, we said destination is the first one, so it will be ex. Remember, the first one is always destination. And then what instruction perform no action. No action, we talk about it, is the NOP function, so that's done. The flags. In assembly language, the CPU has several flags that indicate the outcome of certain operation or condition. These flags are bits in special register known as flag register or E flags. We'll see in the practice later on, we'll see all these flags. There's F, B, F, wherever they call them. Everyone has like for example a set when a carry out or borrow is required for most significant bit. So basically each operation when we do later on it triggers some flags to be adjusted in the CPU. For example, if we say which flag will be set and the result of the operation is 0, operation is 0, set if the result operation is 0, so this is ZF. Which flag will be set if the result of the operation is negative? Operation is negative. Set if the operation is negative, so you set SF flag. Now arithmetic operation, of course, like you're doing the things like that, so it's obvious you can add values, you can multiply, what's this, division instruction. So add destination value, so it's always the first one is destination, add the values. And in the above example, the value can be either fixed value, constant, or register. For a subtraction operation, 0 flag is set if the result of the subtraction is 0. See, we talk about the flags now. If the destination is smaller than the subtracted value, then the carry flag is set. See, this is the flags. All of this, I said, is some mathematical things you can read about. It is AND instruction. The AND instruction perform bitwise AND. All this is like XOR and AND operation. Then you have the OR instruction, they have NOT instruction, and the XOR. XOR, as you know, like it's correct when the 2 is correct and 2 wrong. So I think so, yeah. So in subtraction operation, which flag is set if the destination is smaller than the abstracted value? We talk about this now. If a destination is smaller, then we use the carry flag. We're using the full name or the full name. Okay. Which instruction is used to increase the value of the register? To increase the value of the register, increment and decrement instruction. As the name suggests, the increment and decrement instruction increment or decrement the operand register by 1. The syntax, so we say inc x, so the command here is this. Now do the following instruction have the same results. XOR x and x, or move x, so we move 0 to so the result is 0, or XORing the same. If you do the math the same, it will be automatically 0. And where is that? Therefore, XOR instruction is often used to 0 register, which is more similar to move instruction. So of course here we can say yeah. Sorry. The conditional, so basically all the mathematical instruction we can find in assembly. So the test instruction, test destination source, perform bitwise AND operation. You can guys read about it. I'm going quickly through this. Branching. What branching? There is no when there is no branching, the instruction pointer goes from one instruction to the other. Okay, GMP instruction. What is GMP? I forgot about it. Jump instruction make the control flow jump to a specific location. Okay. Oh, jump to that. Okay. Conditional jump. So there is an if. Often the code required to move if a specific is made. It's like the same like programming in Python or something. If statement and all of that. JZ it means jump if ZF is set. ZF is 1. J and Z. See, there is a lot of things. Without practice, you will never memorize these things. It's small now, like reading to have an idea, the assembly language and things like that. Which flag is set as the result of the test interaction being 0? Test instruction. What flag is set as a result of the test instruction being 0? Should be the 0 flag or not? Which flag is set as the result of the test instruction being 0? The 0 flag. I was confused. I was looking here. So, and then which of the below operation use subtraction to test two value 1 and 2? Which of the below operation use subtraction to test two value? CMP or test? I think the CMP instruction compare two operand set value to flags. The compare instruction works similarly to subtract instruction. This one is an AND operation, so it's the CMP that has subtraction on it. So it's 1. Then which flag is used to identify whether a jump will be taken or not after a JZ or JNZ instruction? JZ and JNZ. JZ is 0 flag, JNC is 0 flag. So basically it's the same answer to the other one. Now the next one is the stack. Okay. Push source. I think if we push, we take the top, or we took from the bottom. I forgot about it again. The push instruction will push the source operand into the stack. The value of the operand is stored at the memory location pointed by the stack pointer, effectively becoming the new top. So wherever you push, it goes straight to the top. Okay, so I remember that. So you start always from the top. Push all the 16-bit generated passages to the stack, all of them. So we have all D. What is D? AD. Push all double word. Okay. The pop it means remove. I think instruction. The following syntax: the pop instruction retrieve the value from the top of the stack and store it in destination. Yeah, take it and put it somewhere else. Okay. What call do? Depend on the calling convention, the arguments are placed in the stack or in the register in a function call. I don't lie to you guys, it's just assembly languages really confuse me. Something maybe I will learn it, I'm not sure. But it's like programming. If you don't practice, whenever they give you this information like that, is more like you get a general idea. Which instruction is used for performing a function call? Function call. Function call, we do this, the call function. So that's straightforward. Which instruction is used to push all the register? To push all the register, push all. So it's push this one. Now we get some practice here for they give us this assembly code that you can follow, and then they give us nice tool here to execute for us. CMP and test instruction. Let's play with this tool. So he said, while running the move instruction, select the move we can do by step or the whole thing. What is the value? If remember these brackets, so it's a memory, so we need to look here. The memory, there's the stack. So we're looking here. The fourth instruction, remember we're starting from 0. So 1, 2, 3, 4. The question is the X memory. It's already here. It's the green part of this. What exactly did move the X to the 4th? Did move the 40th to the memory EX, which is this value. I'm getting confused now. Yeah, the 0, 10, the X, so it's this one. It's here. So 0, 10, the X, moving on, so we move the X. Then what error is displayed after running the 6 instruction from the move? So this is the 4th, 5, 6. We give this error message. Now the stack section, let's give the stack section. That's the stack, it's empty now. What's the value of EX after ninth? The ninth, so it means the 8th. So let's start this one. The value of EX, so it's this one. Running instruction from the stack, the same things. What is the value of EDX after the 12? So 8, we are 8. No, this is 10. Remember, start from 0. So this is 10, 11, 12. The question is, what's the value of EDX? EDX. Who is the EDX? This one. Now run the instruction from the stack section. The stack, let's refresh. After pop ECX, what's the value left in the top of the stack? Okay, the pop ECX, pop, this one. We're looking for this stack here. So let's start it. There. Pop what? ECX. Who is? Oh, ECX is this, so we need to go 1. That's the value. So we have now the value in the stack. Pop ECX, pop ECX. Now it is the command and text instruction, this one. Which flag are triggered after the 3rd instruction? This is the flags. So 1, 2, 3. So parity and 0 flag. So we have parity flag and 0 flag. So we are in the same test. which flag trigger after the 11th, so no, we stop in 10, so this is the 11th, so it is carry and sign, carry flag and sign flag. Now run the instruction from the Lee section, so we have Lee section here. What is the value of EAX after running the 9th? The 9th, it means this number 8 because we start from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. We did 9 here. The value of EAX, so it's this one. Around the instruction from the Lee section, same section, what is the final value found in ECX register? So we are in the 8, let's continue. 9, 10, 11. The final value in ECX, which ECX, so it's this one, that's the final value. And then it's a nice tool. The beta is if you can guess the value without playing with this tool, so you can say the move the 11 to AX and then to EBX, and then yeah guys, that is my best guys. I'm not an expert, but some people asked me to do this video a couple of times and I didn't want to do it because I'm not expert on this, but in case someone find this useful or can make a better video or whatever, this is my best in the case. Hope you like it and have a good day guys. Thank you very much.